This is Dr. Kavita Singh, Associate Professor, Institute of Aeronautical Engineering. So today our topic will be for the discussion is electromagnetic spectrum and its application. So today we are going to discuss about, first of all, what is electromagnetic energy and what are the different regions of electromagnetic spectrum and how it extends from shorter wavelength to the longer wavelength and high frequency to the low frequency. So electromagnetic spectrum is always short wavelength to long wavelength, low frequency to high frequency. This all we are going to discuss in this topic today. So let us enter to the contents what we are going to discuss today. So first of all, we are going to discuss about electromagnetic energy, electromagnetic spectrum region range, electromagnetic spectrum regions, and applications of electromagnetic spectrum. So these are all topics we are going to discuss today. So before we understand about the electromagnetic spectrum, we have to understand about what is electromagnetic energy. So electromagnetic energy, it is consists of electromagnetic waves. So which are electric and magnetic fields that propagate through space. So it consists of electric as well as magnetic fields which propagates through space. Now this energy can take various forms, like it includes radio waves. It converts to various forms like radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, gamma rays. So these are the different regions. The electromagnetic waves will take the form of these all various regions or these all energies. So electromagnetic waves are characterized by their frequency and wavelength, which together determine their energy and properties. So electromagnetic spectrum encompasses all possible frequencies of electromagnetic radiation, ranging from low frequency radio waves to high frequency gamma rays. So all this low frequency regions comes under this regions, radio waves or microwave regions. This all region comes under low frequency. Whereas when you talk about the high frequency regions, all ultraviolet rays, gamma rays, X-rays, this all comes under the short wavelength region as well as high frequency region. So this is the electromagnetic energy. It plays a very crucial role in various natural phenomena and technological applications. So nowadays in our day-to-day life, we are seeing that these electromagnetic radiations we are utilizing in different forms, like in hospitals we use for sterilization process we used, for microwave process we use. So many applications we are using in our day-to-day life. So it's a very it plays a very crucial role in various natural phenomena. It is essential for process such as light emission and wireless communication. Nowadays we are always we are using Wi-Fi or wireless communication we are using. So these all wireless communication is used by this electromagnetic energies. So due to this electromagnetic energies only, we are able to use the wireless communication, energy transfer in electrical systems and medical imaging like X-rays, MRIs. We are all using this electromagnetic radiation in various forms. Various forms in sense, either X-rays, ultraviolet rays, gamma rays. We are using these all forms for various purposes in our day-to-day life. Now additionally, electromagnetic energy is a fundamental to understanding the behavior of matter at the atomic and subatomic levels, as it interacts with charged particles and influences their motion and behavior. So this additional electromagnetic energy is a fundamental of understanding the behavior of its matter at atomic and subatomic levels. It interacts with charged particles and it influences their motion and behavior. Now, before we understand about this electromagnetic spectrum, we have to look on this images. Like in the previous lecture also we have discussed about remote sensing process, how the remote sensing process works. So here the remote sensing process totally works on a one phenomena, and it totally depends on the electromagnetic radiations. In the previous lectures, we have seen that we have two types of remote sensing, that is passive and active. Now the passive part of remote sensing, it is totally dependent on this electromagnetic radiation. So electromagnetic radiation, it involves the electromagnetic remote sensing process. Now you have here different types of elements, like first you see energy source of illumination. Energy source of illumination means this is the sun, this is the source of electromagnetic radiation or energy source of illumination. So whenever the sun is available, then only we are able to do the further process or go with this remote sensing process, that is passive remote sensing process. Now the second thing what we see here is radiation and the atmosphere. Radiation in the atmosphere means it has to pass through from the atmosphere. So this B here is atmosphere, it will pass through the atmosphere. When it reaches to the atmosphere, it has to pass through the different types of layers, right? Then only it reaches to the ground. C is the target. Now this C is the target. So interaction with the target. So first thing what? Electromagnetic radiation through sun, it crosses the atmosphere. Then it reaches to the target. Again, after reaching to the target will give different types of reflection or absorbance or different type of transmittance based on the type of the object. Either it is a rough object or a smooth surface, based on the type of the surface, based on the type of the object. Either it is reflected back or either it is absorbed depending on the object type. Then it will be recorded. This energy will send back to the satellite. Here we have D as a satellite. The satellite is having a sensor over here. So the sensor which is fitted in the satellite will record the reflected energy, and then it will send back to the transmission reception processing. It will send back to the receiver station. This is the receiver station where it will receive the signals and it will receive the data. Whatever energy it is recorded will be received by this receiver station, and further after the receiver station it goes to the next interpretation and analysis. So interpretation and analysis is done based on the data is received by the receiver. Then when you see later, you can go with the application part. So after receiving the data, finally the application part is applicable. So these are the elements which are involved in the electromagnetic remote sensing process. So next, what we have to understand about the electromagnetic spectrum. Now you know about the electromagnetic energy, that is the radiation, the sun radiation, which is having electric and magnetic fields. So it propagates through the space and it is having low frequency from high frequency and short wavelength to high wavelength region. It extends through the regions. Now what is electromagnetic spectrum? So electromagnetic spectrum is a range of all types of electromagnetic radiation, which includes both visible, invisible forms of radiation. And the electromagnetic spectrum extends from low frequency. It starts from low frequency So here will be the low frequency and here we'll be having high frequency. Okay, so it starts from the low frequency to used for the modern radio communication to gamma radiation to the short wavelengths. So in general, the wavelengths and frequencies vary from shorter wavelength, that is high frequency cosmic waves, to longer wavelength, that is low frequency radio waves. So we will understand with better with this picture. This image shows the electromagnetic spectrum. Now see, here we have different regions here. This is one region, 2, 3, here, right? So this region from gamma rays, X-rays, ultraviolet rays. So till ultraviolet rays, from here to here, we call it as short wavelength region, and from visible to radio waves we call it as long wavelength region. Okay, so this portion we have short wavelength region and this portion is long wavelength region, whereas in frequency we call this as high frequency, and from here to here it is low frequency. Okay, so the electromagnetic spectrum extends from short wavelength region to long wavelength region. Either we can say long wavelength region to short wavelength region, and it extends from high frequency region to low frequency. Here we can see short wavelength is high frequency, long wavelength is low frequency. So these are the regions of electromagnetic spectrum. Now in between you can see from here to here there is a small portion which is called as visible region. This is a visible region. In this portion, this is the visible region. This portion is long wavelength, this portion is short, and in center we can see there is a gap over here. This region is called as visible. So this is the total extent of visible region, that is extends from 0.4 to 4 to 7 nanometers. Generally the units will be in nanometers. So this is the visible region. So this is only the region where remote sensing is possible. Okay, remote sensing is possible. That too, which kind of remote sensing? It is passive. So this is only the region where passive remote sensing is possible, because from this region only the radiation can pass through. The radiation will be passing through and it reaches the ground. Okay, whereas in this region, let us understand more better with this image. This is the same image here. Short wavelength. This is long wavelength. Short wavelength, long wavelength, and we have here low frequency, high frequency, and here to here is low frequency. So in low frequency, we have television and radio waves. This is the region. We have microwave region, we have thermal IR region, we have mid IR region. Whereas in the short wavelength region, in high frequency, you have cosmic rays, you have X-rays, you have gamma rays, and this is the short wavelength region. And 0.4 to 0.7, it is the visible region. Now you have blue, green, red. These are the bands in the visible region. So this is only the region where we have remote sensing possibility. Remote sensing possibility. Okay. So this window we generally call as, this is a window actually. This is the window from where the radiation will pass through and reaches the ground. So this window we call it as atmospheric windows. From this window only the electromagnetic radiations are able to pass through and reaches to the ground. Rest of the radiation, out of 100% of the radiation, suppose sun is here, out of 100% of the radiation, 50% of the radiation will be absorbed. 50% of the radiation will be absorbed. Where? In the short wavelength region. Here to here, 50% of the radiation is absorbed. Okay. Now, this is the visible region from where the radiation can pass through and it reaches the ground. So when it reaches the ground, from this window only the passive remote sensing is possible. So this region is for passive remote sensing, and the low frequency region and the long wavelength region, which extends from visible, thermal, microwave, television, or we can say television and radio region, microwave region, thermal IR region, mid IR region, or visible region. So from this region only the active remote sensing is possible. Active remote sensing is possible. Whereas in this region, in the high frequency region, there is no remote sensing possible. It is totally waste for remote sensing. It is waste for remote sensing because all the radiation is absorbed in this region, in the short wavelength region, like cosmic wave region, gamma rays, X-rays region, or ultraviolet rays region. So this region, the radiation when it passes through these regions, it will be absorbed because of the presence of dust particles, gas molecules. The radiation will not at all work. It will not allow the radiations to pass through, and it will not allow the radiation to reach to the ground. So whereas in the visible region, this is only the window. That's the reason we call it as atmospheric window. So this is only the window where the radiation can pass through and reaches to the ground. So this region we call it as visible region. So visible region ranges from 0.4 to 0.7 nanometers. So after 0.7 we have thermal region, that is mid IR, we call it as mid thermal region, or infrared region. Mid IR is mid infrared region, thermal IR region is thermal infrared region. Then you have a microwave region, then you have a radio and television region. So these kind of regions are helpful for us for active remote sensing because it is having the all-time capability. That's why we are able to communicate with the telephones, and we are able to communicate with the television or through navigation and all. It will be possible due to this active remote sensing regions only. So always remember, active remote sensing regions will be only for all time. It is having an all time capability. The active remote sensors are only able to capture the information anytime, any place, at any weather conditions. So this low frequency region is always for all time capability. It is for the active remote sensors, whereas this high frequency region is totally waste for remote sensing, whereas this visible region is only possible for passive remote sensing. So your total electromagnetic spectrum is divided into three parts. One is short wavelength, the other one is visible, the third one is long wavelength region. So short wavelength region is not useful for remote sensing. Visible wavelength region is only useful for passive remote sensing, whereas long wavelength region is useful for active remote sensing. So this is about the electromagnetic spectrum, which is divided into three regions. Now, when you talk about the range of this spectrum, electromagnetic spectrum. So first let us see about radio waves. Radio wave comes under long wavelength region. So the wavelength range from about 1 millimeter to 100,000 kilometers. So this is the range of radio waves. So in this all communication purpose, we are able to, this all sensors, it is helpful for our communication and different kinds of radio waves. Now you have a microwave region. Wavelength ranges from 1 millimeter to 1 meter. So it is having all weather capability like radar, will be helpful in this kind of sensors. Next we have infrared radiation, that is wavelength range from 700 nanometers to 1 millimeter. So infrared radiation, first is radio waves. We are starting from this way, long wavelength to short wavelength. Okay, so long wavelength, we have radio waves here, radio waves, we have microwaves, then you have infrared radiation, then comes visible light. So this visible light is the middle portion here, Visible region, we call it as visible region. It ranges from 400 nanometers to 700 nanometers red. Okay, 400 nanometers violet or blue to 700 nanometers red. Now you have ultraviolet radiation. So wavelength ranges from 10 nanometers to 400 nanometers. This is the region of ultraviolet, X-rays, gamma rays. This three is the region for shorter wavelength. Shorter wavelength. But it is having high frequency. It is having high frequency. So 10 nanometers to 400 nanometers. Then you have X-ray. So X-ray wavelengths range from 0.01 nanometers to 10 nanometers. Now gamma rays wavelengths are typically less than 0 to 0.01 nanometers. That's how these three radiations, these three regions are totally waste for remote sensing, because here the radiations will reach, but it will be totally absorbed. It will not allow the radiation to pass through, and it will not allow to reach to the ground. So only possibility from the electromagnetic spectrum what we have is from visible region as well as from the active region. So visible region, it is possible for the passive remote sensing, whereas for the long wavelength region, it is possible for the active remote sensing. Okay. Next, we have electromagnetic spectrum regions. So this is the description about the regions. Like radio waves, these have the longest wavelength and the lowest frequency in the spectrum. So they are used for telecommunication, broadcasting, radar. And microwaves with slightly shorter wavelength and higher frequency than the radio waves. Microwaves are used for cooking, communication, and radar. So these regions are very much helpful nowadays, and as it is a longest wavelength regions and it has a very low frequency, so it is helpful for the telecommunication broadcasting purpose and radar or microwave purpose. Now next we have infrared radiation. So what is infrared radiation? Infrared radiation, this segment has wavelengths longer than the visible but the shorter than the microwaves. These are longer than the visible light, but they are shorter than the microwaves. So it is commonly associated with heat, and it emits by warm objects. And infrared is used in night vision technology, remote sensing temperature, and sensing infrared astronomy. Next, we have a visible light. So this portion of the electromagnetic spectrum that the human eye can detect, it ranges from shorter wavelength, violet and blue, to longer wavelength, red and orange. So different wavelengths within the range can correspond to the different colors. So visible light is basically for detection of, it's like a electromagnetic spectrum of the eye can detect. So our eyes can see whenever the visible light is available, then only our eyes can see the objects. Otherwise, we are unable to see the objects. Whenever the lights are available, then only we are able to see the objects. Next, we have ultraviolet radiation. So with wavelengths shorter than visible light, ultraviolet radiation is not visible in human eye. It's known for its effects on human skin. So ultraviolet radiations, it is not at all visible as it is a shorter wavelength, and it is not at all visible, and in this region the radiations are totally absorbed, and it is known for the effects on the human skin, and like sunburn happens due to this ultraviolet radiation when it reaches to the ground, or when the ultraviolet radiations it just passes through the atmosphere, then it creates a very huge problem for the human skin. Now next we have X-rays. That's why we have a ozone layer over in the atmosphere. So nowadays the ozone layer is getting thinner and thinner. So the ozone layer is only helpful to control this ultraviolet radiation, where the radiations are totally absorbed in that ozone layer. So if suppose the ozone layer is not present, that radiation will reach to the ground and it will affect the human eyes and skin. Okay, next we have X-rays. These have even shorter wavelength and higher frequency. It's basically from the shorter wavelength portion, and it has a higher frequency region. And then ultraviolet radiation X-rays are used for in medicines for imaging bones and internal organs, as well as in industry and security screening and all. It is used as a application. Now, when we talk about the gamma rays region, so with the shortest wavelength, gamma ray is the shortest wavelength and highest frequency in the spectrum. Gamma rays are highly energetic. They are highly energetic. They produced by the radioactive decay and nuclear reactions. Gamma rays are used in cancer treatments and in various scientific and industrial applications. It is useful. So these are about the regions of electromagnetic spectrum. Now, when you talk about the applications, it has a very huge application. Nowadays, our before also we have discussed, like in our daily life, we are using these radiations, the electromagnetic radiations in various forms to for the treatment of humans, for the treatment of plants, and for treatment of the water bodies or treatment of the water, processing of the water. So this all process we use it nowadays in day-to-day life. So it plays a very important role in our daily life. So application, when we talk about the application of electromagnetic spectrum, so electromagnetic spectrum finds applications across a wide range of fields, including communication, medicine, astronomy, industry, and research. Here are some of the key applications, different segments of electromagnetic spectrum. So let us talk about first of all radio waves. So before our slide also we have discussed few of the applications, but here in detail we are discussing. So broadcasting, radio waves is very much helpful in broadcasting. What is broadcasting? Like radio waves are used for broadcasting AM and FM radio as well as television signals. So daily we are able to watch television without any disturbance because of this radio waves, as it is a active sensor, as in this region the active sensor works, so it gives us the all time capability, so all time we are able to watch the television and the radio signals. Next we have a telecommunication. So radio waves are very much important in the telecommunications, like mobile phones, Wi-Fi, other wireless communication technologies utilize the radio waves. Like Wi-Fi, we are generally everywhere it is applicable. All the companies, all the workplaces, Wi-Fi we use. That is due to the radio waves. It is possible. And telecommunication, all the mobile phones, all the uh, tele options are based on this wireless communication. So this is very much important region, and radio wave is very much important for the communication purpose, navigation purpose. Next, when we see the radio waves, next applications, it is about the radar application. So radio waves are used in radar systems for navigation, weather monitoring, air traffic control, military purposes. So radio waves are very much important in the navigation purpose, monitoring of the weather, air traffic control. It helps us, and in the military purpose, it is very much important nowadays about the finding the exact location of the flight. We are just applying this radio waves for this purpose. Now, when we talk about the microwave, how we use in our day-to-day life, microwave application is also having a very huge application. So, first thing is like microwave ovens we are using daily. So, microwaves are used in the household, microwave ovens for the cooking of the food. Cooking of the food, we are using this microwave as a sensor. In this region, this radiation are used for the cooking purpose. Then we have a satellite communication. So in this microwaves region are used for long distance communication via satellites. So in the satellite communication, in the active portion of the electromagnetic spectrum, then we have this active sensors. So these active sensors, in the radio region, they are able to capture the information of all weather conditions. Anytime the weather communication will be providing us. Next, we have a radar again here. So microwaves are also they are employed in radar systems for various applications, including weather forecasting, aircraft navigation, speed detection. So these all will helpful us in the forecasting the aircraft and all, and speed detection also it is very much helpful. This is a very good application and very important applications. Next, we have infrared radiation. So infrared radiation nowadays we are using in the night vision. Like infrared radiation is used in the night vision technology for surveillance or security or military applications like cameras we install. There we use the infrared radiation for the security purpose. We use the infrared radiation. Even in the military purpose, we are going to use this infrared radiation. And remote sensing also we use. So remote sensing infrared sensors are used for remote temperature sensing, like some places to find out the actual temperature. These sensors will be helpful for us to finding out the temperature in such area, and it will be helpful in the environmental monitoring and agricultural applications too. Now, infrared stereo spectroscopy, if you talk about the spectroscopy, so infrared spectroscopy is used in chemistry and science for analyzing the molecular structures. So this is also very much helpful in our application of day-to-day life, like how we are using it for the security purpose, surveillance purpose, for remote sensing purpose, for agricultural purpose. We use it for infrared spectroscopy. We use it. Next, when we talk about the visible light, so visible light, it is like this is the portion. This visible portion is the portion where the passive remote sensing is possible, and this application we have in lighting. Like visible light is using various lighting technologies, including incandescent bulbs, fluorescent lamps, LEDs, and lasers. We use this visible light. And the photography and imaging, we use the visible light. Like visible light is used in cameras, imaging device, optical instruments for capturing images and videos. So visible light is helpful whenever the visible light is available. So this is very much helpful in the lighting purpose in day-to-day life, and it is very much helpful in the photography and imaging to capture the information with the help of the cameras, with the help of the instruments and devices. Now we have optical communications. Fiber optics cables are used for visible light, like fiber optical communication, like fiber optical cables are used for visible light for high speed data transmission and over the long distances, like internet cables we use it. So optical communication also it is very much helpful, this visible light. Next we have ultraviolet radiation. So what is ultraviolet radiation? So this is the ultraviolet radiation is the short wavelength portion region. So in the short wavelength portion region, this region is totally absorbed. When the radiation falls in this region, it is totally absorbed. But still, these radiations are helpful in our day-to-day life. We are using it in sterilizing, tanning, fluorescent lighting. So sterilizing, it is used in the UV radiations are used for the disinfection, sterilizing in water treatment plants, hospitals, food processing facilities. So when we talk about the wastewater treatment process or normal, generally we talk about the water treatment process because nowadays the water is not purified to drink directly. So we have to go through a treatment process. So in that treatment process, we have to use these UV radiations for the killing of the bacteria and making the water potable to drink. So this water treatment, it is very much widely applicable for the sterilizing. So in all this water treatment plants, this UV radiations are used for the final treatment of the water. So final treatment of the water when you drink, for a drinking water purpose also, after it goes through a many treatment process, so final treatment it is given by the UV radiation to kill the final bacteria from the water and it is ready to drink. So it is very important for us, the ultraviolet radiations we are using in this whole process. And then we have this tanning. Tanning, like UV lamps are used in the tanning beds for the artificial tanning. We use it. And then we have fluorescent lighting. Fluorescent lighting is like UV radiation is used to excite phosphors in fluorescent lamps producing the visible light. Now, next we talk about the X-rays. So X-rays are very, very important in our medical field. When nowadays in all the hospitals we use this radiation, that is X-ray. It is very much harmful, but it is used for the treatment purpose. So medical imaging, X-rays are used for the medical imaging techniques such as X-ray, radiography, CT scans, fluoroscopy for diagnosing the injuries and diseases. So nowadays in all the hospitals, these X-rays are used for the diagnosis process purpose, and CT scan and X-rays they do for diagnosing the injuries inside the body, and whatever disease they are having, the patients are having, they are able to identify the diseases based on this X-ray radiation. Now we have industrial testing. X-rays are used for non-destructive testing of materials in industrial applications such as inspecting welds, pipelines, and aircraft components. It's very much helpful in the industrial testing also. So X-rays are used for the non-destructive testing, like they have to find out about the material testing or industrial applications, such as they are able to inspect the welds or pipelines and the aircraft components. Okay. So I think till now we whatever we have discussed about this electromagnetic spectrum from the shorter wavelength to the longer wavelength, and from the high frequency to the low frequency, and it is widely applicable in the various fields. We have seen the applications. So if we observe a day in our day-to-day life, daily we are using this kind of radiations, electromagnetic spectrum radiation, like either with a telecommunication or television process or Wi-Fi. So when you're going to a workplace or you're at home, we are utilizing this all radiations in our daily life process. So these radiations are very important in our household process as well as in our workplaces. So these are some references when you want to know about the more content about this. Just you can refer the book like in Anji Reddy book. So this is the author. He is the author of this book, and it is about the remote sensing in GIS. So it gives the total content about the remote sensing process, the working of remote sensing process, and how the remote sensing data is applicable to the GIS process. This all information is given in this book. So you can kindly just go through this book for the more content. And it is publication is from the BS publication from Delhi. So this book will be very much helpful to finding out the more content about this electromagnetic spectrum and its application part. We can just go through it. Next, we have a Fundamentals of Remote Sensing by George Joseph, University Press, Hyderabad. So if you want to refer the another book that is about the remote sensing fundamentals. So right from the basics, it will tell you the information or the content which covers in this book. It will tell you about this all contents. So you can just go through this book for this remote sensing fundamentals. Now, if you want to know more about the application part of the remote sensing, you can just refer this Narayana. This is from the remote sensing and its applications. So it is from the University Press, which will give you the more and more information about the application part. Like this, we have more references here. Like S. Kumar is also one of the good book for the basic remote sensing in GIS from the Lakshmi publications. And you have this Tangchan GIS, which is from TMH publication, and this book will be very much good for the GIS part. Like if you want to know more about GIS content, which we'll be discussing in the coming topics, this content you can more find out in this Tangchang GIS book. So this is a very good book for referring the GIS portion of this content of this course. So remote sensing GIS by Bhatta also we have from the University of West New Delhi. These books also we can refer. So these are all references which you can refer it for more information, and you can just go through the content and just find out the more type of information you want to know. So I think that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.